And I'm going to block that in. This will be right. It's too close. Somewhere. A little bit. No, we'll try it. See if that works. Just put it up here. Pretty funky. Alright, well, we'll see.
Alright. You guys, a couple things. So, I'm pretty new to the format of this course. So I'm not new to my math lab. I'm not new to any of that. But I haven't, like I think I told you the first day, I haven't taught this course where you break it up and go through the labs. So we're all going to feel it out together. The way two groups have had labs so far. One more group after this class is going to meet with me. What we're doing in there is registering in my math lab. If you haven't done that yet, there's a little orientation you have to go through. It kind of shows you how picky the my math lab can sometimes be. Some of you guys have experienced that. And real quick note on that, if you ever put the right answer in and it tells you it's wrong and it's some kind of little formatting problem, there's a little place, question help, ask your instructor. You can just send a little note to me saying, can you check this? And if I agree with you, I'll give you the point. Does that make sense? I have ultimate power. I can override the computer and give you some points. If I agree that you should get some. Yes?
So what happens if it only gives us 3 chances to get the correct answer. So what happens if we go through all 3 of them and it basically is like, no, would you still be able to overwrite it if it's correct?
Oh, if it's correct?
Yeah, after we've already taken up our chances.
If the answer you're trying to put in is correct and it's a formatting issue or something, then yes, I'll give you the point. If you use up all the 3 attempts because you're putting the wrong answer in.
Well, no, I mean because it's not giving it the right answer because of the formatting error.
Formatting errors, I'm going to try my best to not let that get in your way. To me, that's why I don't like online homework in general, because the systems are so picky. What's nice with this class is it's not an online class. I'm right there, so I can actually see when there's a formatting issue. Or you just email me and show me, I can look at your attempts and see if I agree. Is that everybody with me so far? Now the section that hasn't met yet, and you've never used my math lab before possibly, you don't know yet, but you're going to find out soon. 11. Let's see, where else do I want to say? The lab time is going to be when we do quizzes. And it's also going to be when I might have some group work for you guys to work on. So there will be some stuff we'll do in the lab that is not going to involve the computer, which is nice for me because I actually want to see some work. So in the computer, you don't have to show me the work. But without the work, I can't see how you're thinking. And that's really, I need to be able to see that to help get that the right way. Any questions about how this class will work?
I have a question.
Yes.
I'm actually here because I'm trying to crash it. I registered for the wrong class.
Neat.
So, as I was looking at your times or whatever, so there's 3 sections here? Or?
Yes, there are.
Okay.
See me after.
Sorry, yeah.
I actually have some room, so I can maybe let you in. We just have to be careful about which section you want, because it depends on the lab time.
Oh, okay.
So see me after.
Okay.
Let me see. Any other questions about anything? Yes?
So if we make up a quiz or a test, can you take it home something, or do we have to go through that? Or not make up, I apologize, you said you could
make corrections?
Yes.
Okay. Yeah, you can get anybody to help you. It's just don't copy from somebody, right? And what's really kind of, it would be funny if it wasn't so sad, is I give multiple versions of a quiz and a test. So I love when somebody gives me the corrections and it's all the right answers for another version of the thing than what they had. I'm like, if you're going to cheat, make it a little harder for me. I mean, that's no challenge. Give me a challenge. You got to put a lot of work into it if you want to cheat correctly. So I'd rather just learn the stuff. Anything else? Yes.
You get questions gotten on the online homework. How much of your grade will that affect?
So the way I'm going to do the online homework is, even if you don't get every single thing right, you can still get full credit as far as I'm concerned. And that's the way I do my out of the textbook homework. I allow for a few mistakes. But there are certain problems that if you get it wrong, it was a crucial problem or something, and then you'll get a little less credit. So the actual grade that my math lab shows you for the homework is going to be kind of lower than the grade I'm going to give you for homework. Does that sort of make sense? I allow a few mistakes because we're a freaking human. It's going to happen. But there will be certain questions, or if you make a lot of mistakes, then it's going to affect you. Is that kind of understood? You guys understand? A little bit? All right. Anything else about technical stuff? Okay, so like I said before, the labs are going to be where I'm going to have time at the beginning of the lab to take questions about homework or whatever. The homework is going to be online. The lab are going to sometimes be doing extra little group work or something, but I always leave some time in the lab for you to work on homework, so you can knock some of that homework out. Especially if you realize Chapter 1 homework is 100 questions long. What the shit? Because Chapter 1 homework on my math lab covers all the sections of Chapter 1 in one assignment. So yeah, not every assignment is going to be 100 questions long. Don't get too freaked out. All right, how we doing? Everybody all right so far? A little bit? Okay. So what I want to do today is I want to lecture on Chapter 1 stuff. I'm going to give you guys a few problems to try out. We'll see what you guys think. And then hopefully tomorrow we can kind of start to transition into Chapter 2. Chapter 2 is all about solving equations. And I'm going to treat it as if you've never seen it before, but most of you guys should be able to solve some basic equations. We'll see. So the little notebook, we're going to start using that tomorrow because it doesn't start with Chapter 1. So we can't use that yet. Keep hearing the number 100 in people's conversations. You guys will eventually get over it. Okay. So Chapter 1 really is a review. Now, there might be little parts of Chapter 1 that your teacher didn't really cover in depth or that you just completely forgot. So you desperately need to look through Chapter 1. That's why I gave such a large Chapter 1 assignment. Most of the problems in that assignment should be pretty quick, unless you forgot completely what the hell they're talking about. So for example, we're going to talk about the properties, commutative property, associative property. Right? Some of you guys might be like, those words sound familiar, I have no idea what the hell they mean. Right? But let's start with this. One little thing that's actually in the very first section is translating from English to Mathish. Right? And of course, if you haven't heard yet, I'm sure you guys realize this, math is a foreign language, which is why it is so difficult. Right? Math is my first language. No. Sometimes it seems like it, especially the way I write. So if I said, translate this from English to math, if I said, like, 28 less than a number. 28 less than a number. I'm kind of leaving it up to you, too. I mean, what is the number that 28 is being taken away from, right?
Another
We don't know, so you can make it whatever you want to. So you can make it the standard x, you can make it the second standard n, or you can make it anything. You can actually make it a little box. You can make a little house. It's just a symbol that represents the thing I don't know. That's all a variable is. And of course, that's why we call it variable. It's because it represents a quantity I don't know, and it could vary depending on the situation. So how would I? So this is. I start with this one because this is the hardest one. It's got a little freaky grammar thing. What's wrong with this? Or is that wrong? And maybe it's a trick.
That's wrong.
That is wrong. Right? If I said I'm 44 years old and you are 28 years less than that, you wouldn't do 28 minus 44 because you'd end up with a negative number, which means you are not yet born, which is freaky that I'm talking to you. Do you guys understand? So this is not math's fault. This is the grammar of English. 28 less than a number is the number minus 28. If I have 10 apples and you have 7 less apples, it's not 7 minus 10, it's 10 minus 7. You guys, quick. So it shouldn't be this. So please, dear God, if you wrote that in your notes, cross through it. That is wrong. It's x minus 28. Cool. What about this? The product of a number and 14. So first off, you have to remember what the hell product means. Multiplication, I love it. And once you know what the operation is, you just have to apply the operation. Now what's kind of wrong? So what should the answer be? How to translate this into math? Yeah, so if you do x times 14, you are technically not wrong, but what's conventionally wrong? If I write x times 14, how should it be written? 14. So please, dear God, I'm not coming down on you. You were brave enough to say something. This is not technically wrong. It's just convention to write the 14 in front. I love it. So we all know that if something's sitting next to something else, that means multiply. I love it. Okay, nothing groundbreaking yet. Let's see, the final one I want to do is something like this here. The sum, well, let's do this. The difference between 11 and twice a number. The difference between 11 and twice a number.
2x minus 11.
And so this one, this first one is the evil one. 28 less than a number is actually turned around. This one, the difference between 11 and, how do I write twice a number? Careful now. Twice specifically means 2 times, right? Double. I'd have to say squared to mean squared. So be careful. It's 11 minus 2x. The only evil one that makes the 2 turn, because it's English grammar, is when I say something less than something. That has to turn around. So watch. What if I said the quotient? The quotient, oh shit. The quotient between, quotient of 11 and twice the number. So that what are the 2 quantities I'm still working with? 11 and 2x. But now what am I doing between them? Dividing. Quotient means division. Which one I'm going to write on top? The first one I see. 11 divided by 2x. 11. So that's actually in section 1.1. So if you need some extra practice with that, there's that little thing in the My Math Lab. Those of you that have been in the lab so far, it says extra practice. You can actually go in there, click on chapter 1. You can do extra practice on any section you want to. Since we have this up here, let me ask you something. Now, x normally is any number I want it to be. Can anyone tell me in this problem, is there a number that I cannot put here for x? 0. Why can't I put 0 in for x? Can't divide by 0. Why not? Gives errors. I love it. Calculator sometimes gives errors when actually it shouldn't, to be honest. Calculators aren't perfect. We're humans. We made them. We should be a little better than them. So watch this. What is 6 divided by 2? That's amazing. It's 3. Oh, look. Why is 6 divided by 2 3? Use the opposite of division to describe it to me. Because 2 times 3 is 6. So what is 6 divided by 0? It's got to be the number such that when I multiply it by 0, I get 6. Is there a number defined to do that? So then it's undefined. You guys with me? So you don't just accept anything that any math teacher says, just go, that's the way that is. No, why is it called undefined? Why did you just call it freaky or error? Or why did you call it undefined? That's why. There's no number defined to do what that wants it to do. How are we doing so far? Anybody else, teacher call it something else? Dividing by 0? Anybody ever call it infinite? Yes? Because think about it. What's 6 divided by 2? 3. What's 6 divided by 1? 6. What's 6 divided by a half? 12. 6 divided by a fourth? 24. So 6 divided by 0 is the limit of that. Well, that just kept going up. It's an infinite. Just in case anybody ever called that infinite, that's why. 0 is the smallest number you can divide into something, and it ends up with the biggest output possible, which is infinity. Okay. Now, of course, infinity is a process, but we're not going to go into infinity. Let's do this right now, because somebody was asking about it earlier. And this isn't the most important thing in the world, but I still want you to be able to differentiate between these things. Let's start with the one that should be the easy one. What is the distributive law, or distributive property? What does that relate to? So if I had 3 times x plus 2. Yes, sweet. Anybody ever see why that's true? What does order operation say I have to do first? In the parentheses. What the hell is x plus 2? I don't know. So somehow, now this should bother you on some level, right? You should be like, why are you talking about grammar, order operations? Please excuse all kinds of dumbass sons or whatever. And then all of a sudden you just go, well, screw it. It should bother you. You should be like, why are you allowed to break the rules? Why can't I? And it's not really breaking the rules. We're reorganizing it so I have a different set of rules I have to follow. So what I mean is this. What does 3x actually mean? Don't use multiplication. No, see? No, don't use multiplication. What does 3x mean? Oh, shit. What's x plus x? All right, so what does 3x mean? Yes, x plus x plus x. It means 3x is adding. So I can write this as x plus x plus x. How are we doing so far? Okay, maybe. Now, on one level, I want you to realize, I know so many guys right now are like, I know distributive law. What the hell's wrong with this guy? Don't explain this to death. But on the other hand, do you really know it? Do you know why you're allowed to do it? That's what I like to explore in a math class is, don't just know how to do something, know why you do it. Then math, you can make a lot more connections that way in math. So if I can write 3x as x plus x plus x, what's 3y? Y plus y plus y. And what's 3x plus 2? X plus 2 plus x plus 2 plus x plus 2. And of course, what can I do there now? Yeah, combine like terms. X plus x plus x, 3x, 2 plus 2 plus 2, 6. Now the other thing that happens is, I just showed you why distributive property works. I'm not saying you have to do it this way. Dear God, what if that was an 80? Don't be taping pieces of paper together to get your whole problem to turn into me. Holy shit. This is why it works. Never do that. Just understand why you can make this shortcut. So it's not breaking order operations. It's using the definition of multiplication to write it a different way. All right, how are we doing so far? And you got to love the name distributive property. I'm distributing the 3 through. That makes so much sense. Do that more often for us, math. All right, I like it. So the next two, oh well, math didn't quite do that for us. Commutative versus associative. So the commutative property would be something like x plus y plus 3 equals x plus 3 plus y. And in fact, do this for me. Put parentheses around the y into 3 like that. That doesn't change anything. And what is that really saying? Is 7 plus 2 different from 2 plus 7? So all it's really saying is you can add whatever order you want to. What other operation can I do whatever order I want to? Multiplication. So I could have said x times y times 3 equals x times 3 times y. That's still commutative property. And the way that I personally remember this is each of us as individuals commuted here to school. You commuted. So when individual things move, that's commutative property. When parentheses get up and move, that's associative property. So individuals commute, parentheses associated. So if I had this instead, x plus y plus 3 equals x plus y plus 3. That is associative. Because what actually moved, the freaking parentheses moved. Okay. That's all the time I want to spend on that. You shouldn't make a mistake between the two, but it isn't the end of the universe if you can't differentiate between the two. Okay. I like it. So this is in section 1.2. Now let me give you my little spiel about types of numbers. Real quick, do you guys know why our number system is based on 10? Because we have 10 fingers. If you go 40, if I ever teach 120 again, you take my 120, I teach you what would it look like if we had 8 fingers. Let me not take the thumbs away or else we don't evolve. So what if we only had 8 fingers from the beginning? What would our number system look like? We wouldn't have a number 9. We wouldn't even have a number 8. But let's not go there. I don't want to forget answers. So our number system is based on 10. Let's talk about the types of numbers we have. So the numbers that came to us naturally. And what I like to talk about is back in the caveman days. You're walking around. You need to have a rock so that you could kill something so you can eat it. Right? Maybe eventually you learn to sharpen it and kill things better. You guys with me? All right. So I have one rock. Maybe you got 2 rocks. Hey, dude, wow. All right. Or you got a little collection of rocks and everybody's like, oh, look at him. All right, you guys with me? So those are the numbers that came naturally to us. 1, 2, 3. Those are normally called the counting numbers or the natural numbers. Okay? So the natural numbers. 1, 2, 3. Now something that's kind of interesting, I also teach in 120. I teach Babylonian numbers, Egyptian numbers, ancient Chinese numerals. Yeah, I love that class. It's a kick-ass class. What's really kind of freaky is there were entire civilizations that knew numbers, but they didn't have any symbol for 0. The idea of 0 had to be created. Right? In fact, a study of math is really just catching up with all the shit that humans have come up with so far. It's really what math is. So, like the Babylonians, they had no symbol for 0. They just had to leave a space and pray that people understood what it meant. It wasn't quite that bad, but it was actually kind of close to that. So eventually they came up with the idea of 0, but then their civilization collapsed. Not because of 0, but it's like, oh, 0, oh shit, we're all dead. So I love the name of this. When you add 0 to the list of numbers you have so far, it's called the whole numbers. Because you added the freaking number that looks like a whole. Let that be easy to remember. So the whole numbers are 0. 1, 2, 3, forever. Alright, so I say my little caveman, he's got his weapon, he chucks it into some thing's neck and it runs off. He's got no weapons. So he has to come up with the idea of 0. So if he's got no weapons, he's going to have to go to that dude with all the freaking weapons and do what? He's going to have to borrow, which I then have to come up with the idea of negative. Right? I owe you something, negative rock. Oh shit, I owe this guy. So then I come up with the idea of integers. Now these are words you've heard before, but I don't know how deep you got into what each one was made up of. So now I have to do the little dot, 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 -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. So basically, I always like to think of it as a mirror image on the other side of the number line. We include those numbers now. And here's something really freaky. When people first came up with the idea of negative numbers, there were other people that were like, well, that's crap. They don't exist. Those are imaginary numbers. Those don't exist. Nowadays, we understand all too well that they exist. Especially college students. I lived a very plastic life to make it through grad school. So I was definitely in the negatives most of the time. Right? So we know that negatives exist, unfortunately. So let's say he borrows that rock, and then he drops it, and it cracks in half. Right? So now he's got to come up with the idea of fractions. And what we call those numbers, what is a fraction? What's the official kind of technical word? It's a blank of two numbers. Ratio. So we call these kind of numbers rational. So this is everything, all numbers that can be represented as a fraction. And you got to love the root word of that ratio. Right, so that'll remind you, oh, it's got to be a number that can write as a ratio. Obviously, the bottom can't be 0. Now, let me see. I want to try something with you guys, just to finally show you some computation stuff. So let me give you an example of a rational number. What's an obvious one? 1/2. Probably the one that I just said. It's the most obvious one. Give me another example. 1/4, 3/4. I love it. So 1/2, 3/4. What about 7? Yes, because 7 is over. We just don't write it, but we know it's there, right? That's that understood one business. That's everywhere. Okay. What else? What about, does anybody know what 1/3 is as a decimal? Yeah, most of the time people know that 1/3 is 0.3333 forever. So then 0.33 forever is rational because it can be represented as a fraction. Holy shit. So basically any decimal that has a pattern to it or stops. So 0.3333, you put a 0 there so you guys can see it. And remember that little line means keep going, I got tired. That's 1/3. What about, somebody says, yeah, I'm tired, dude. What about 0.127 where it stops? What is that as a fraction, 0.127? How do I write that as a fraction?
127 over 1,000.
Beautiful, right? Tenths, hundredths, thousandths. I like it. In fact, really quick, decimals are fractions. They're just over a multiple of 10, so they fit into our number system, and that's why we can write them as decimals. A continuation of the place values that we have. Maybe? Not really? Okay, sure. So 0.127 will be 127 over 1,000. I love it. What about this, though? What about 0.1111 forever? Like we just said, we should be able to write that as a fraction. Nope. I love it. Nope. So you're coming up with like estimations. I want to know exactly what it is. So I'm going to show you right now. I'm going to show you. Right, is everybody with me? I mean, 111 over 1,000 isn't quite right because it's going to stop at the third one. Does that make sense? I need the fraction that I write to actually be ones forever. And then part of your brain goes, how the hell am I going to do that shit? Right? So stay with me. What I'm about to show you is nothing that you have to be able to do on your own yet. Right? But I want to show you this. Okay. So here's the beautiful thing about algebra. And I know you guys are not ready to say that yourself. But what algebra does for us is it allows us to work with stuff when we don't know what it is. That really is part of what algebra does, right? How much did Frank make? I don't know, but whatever you made, you made twice as much. So 2x. Oh, okay, great. So here, what is 0.111 as a fraction? Do we know? I don't have a freaking clue yet, so I'm going to call it x. And you're like, yeah, great, that's so much better, Jeff. But now, somebody help me out. Why was this problem hard? Because the ones never freaking stop. If only I can kill them somehow, cancel them out. So this is a neat little method. If I multiply this by 10, what happens? So I get 10x on this side. What do I get when I multiply this side by 10? What happens when you multiply a number by 10? The decimal moves once over, because every place gets 10 bigger. So they all go one place up. So this side would become 1.111 forever. How are we doing so far? And again, this is just something for you to watch and go, oh, okay, shit. Right? It's not something that you have to understand. So now look what I can do. Look what I can do. I can subtract those two. Right? What's 10x minus x? No. What's 10x mean? 10 times x. What's the only way to kill multiplication is with division. I'm not dividing. What's 10x minus an x? 9x. Okay. Right. You guys with me? 10x's minus 1x leaves you with 9x's. I like it. Thank God that wasn't graded. So 9x. And then what happens here? This is really kind of cool. What did I just say? The stupid ones forever suck. But what's 1.1s forever minus 0.1s forever? These two just cancel. And I get 1. And didn't x represent what the answer was going to be? So if I solve for it, I have the answer. How do I solve for x? Now, if you did 1 divided by 9 in your calculator, it's going to do 0.1111, and then the screen ends. You guys with me? So if 1/9 is 0.1111 forever, what's 2/9? 2 forever. What's 3/9? 0.33. And what's 3/9 reduced? Freaking third. Which is what you guys, most of you already knew, was 0.33 forever. Okay, maybe let me stop. That's not how. Obviously, some of you guys are like, who cares, whatever. But some of you guys are like, oh, okay, that's kind of cool. Right, I like it. So, of course, 4/9 would be 0.444. You could do the same trick if it was like 0.262626. I just have to multiply by 100 instead of 10 so that the 26s would match back up. Why did I only have to multiply 10 here? Because I just needed it to move over once. Here I have to make it move over twice. I do the same thing I just did, but multiply by 100 instead. Maybe. And again, will that help you buy lettuce? No. I don't give a shit about buying lettuce right? This is still, if you know this, you're a little bit better off than you were before you did. Right? What did I... Oh, yeah, rational. And then finally, well, that was all a little side note. That's all about rational numbers. So everything left, we call them irrational, which makes sense. If you're not rational, you are irrational. And some of you guys know all too well about dealing with irrational people. But what's an example of an irrational number then? So what's it got to be true? It can't be represented as a fraction. It can't be a decimal that stops. And it can't be a decimal that repeats. So it's got to be a decimal that goes forever and has no pattern to it. Right? So there's a famous one that everybody knows when you study. Yeah, pi. I like somebody's point at my shirt. So an example of an irrational number is pi. But what about square root of 2? Any square root that you can't do is also rational. Square root of 2 is 1.414, blah, 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 forever and ever. Well, what's the square root of 9? 3, so that's a whole number, right? That's actually a natural number. You can go all the way back there. Okay, how are we doing so far? Is that decent? Okay, I like it. And these are all, of course, all of these are examples of real numbers. There's a whole other group that goes outside of that that's called complex numbers. We're not going to worry about that yet. So you're like, why did you say that, Jeff? Just to let you know. There is something outside of there. Okay, so what about... I'm just scrambling for paper. Oh, if I ask you to do this, this should be bread and butter kind of problem. So can you write the prime factorization, of 48? Take a minute and try to write the prime factorization of 48. If you forgot what that means, just look at your person next to you and say, hey, what the hell's that mean? Or just wait a minute, we'll talk about it. Let me help you out a little bit. All right. So somebody tell me, what was the first step you did? All right, so you could do 2 times 24. You could do what else? 4 times 12. You could do what else? 6 times 8. You could do 3 times 16. It doesn't matter which way you pick because you're going to slice it all the way up anyway. Everybody's going to agree at the end. Doing this is what I call getting the DNA of the number. Because I'm weird. But also because it kind of makes sense. So if I do this, 24 is 2 times 12. And of course the 2's are prime, so I kind of circle those little fruits hanging off my tree. 12 is 2 times 6. And 6 is 2 times 3. So what do I end up with? I end up with 2 times 2 times 2 times 2 times 3. And I like it. You can write that better as
2 to the 4th.
2 to the 4th times 3. So that, I call it the DNA of 48 because no matter what you do, this is going to be 40 freaking 8, right? So this is like the parts of 48, the DNA of it. Sweet. So if I ask you to do a prime factor tree or to write all the prime factors, this is what it means. And this should be, like I said, bread and butter. Now, real quick, here's something that I'm surprised not more people know. And it's not your fault because I don't think they teach it as much anymore. How do you know if a number is divisible by 3? I mean, 2 is easy, right? Please. How do you know a number is divisible by 2? If it is even. That's basically the definition of even, if 2 goes into it. How do you know a number is divisible by 3? Does anybody know? So, if the number, so here's the number that's divisible by 3. You ready? 1, 4, 1, 2. You can do it, Jeff. Can you do it? Yes. Yes, if it adds up to a multiple of 3. If all the digits in your number add to be a multiple of 3, then 3 goes into it. And in fact, I said that to one in class of mine, and they got angry that nobody ever told them this. But see, this is one of the things they decided, why do we need to teach students that? We got calculators, and then all the math people in the world go, what the hell's wrong with you? So what, we got calculators? I still want to know that shit. I'm a human. I want to know how these numbers work that we made up ourselves, right? Do you guys even know what our number system is called? It's just one number system. It's called the Hindu Arabic numeral system. So the numerals we use, what is that, by the way? Is it ice cream? The numbers we use are from Hindu Arabic. It's from Arabic numerals, right? It was influenced by Hindu stuff. So that's the system that we've chosen to use. The Chinese used to use different numbers. Different civilizations use different numbers. When I teach Mayan numbers are pancakes and blueberries. Like a line with 2 dots on top would be the number 7. But I always think it looks like pancakes and blueberries. So I don't know if there's any Mayans. Real quick, so this is if it adds up to be a multiple of 3, 3 goes into it. If it adds up to be a multiple of 3 and it's even, 6 goes into it. Why does that make sense? If it's even, what goes in? 2. If it adds up to be a multiple of 3, 3 goes in. So if 2 and 3 go in, 6 goes in. Are you starting to see? How can I tell if 4 goes in? Here's a number that 4 goes in. Wait, let me finish this up. 3 goes in, 1 plus 4 plus 1 plus 2 plus 1 is 9. And that's a multiple of 3. That's why that works. Here's a number that 4 goes into. 7149266666712. The reason I could do that so quick is, how do you test to see if a 4 goes into a number? If the last 2 digits are divisible by 4. Then 4 goes into the whole thing. Why does that make sense? Because 4 goes into 100. Therefore, 4 goes into 100 plus any multiple of 4. The minute you got that, you got everything. So as long as the last 2 are divisible by 4, the whole number is divisible by 4. And I know that calculators exist, but this kind of thing is really nice to know how to check something real quick. I mean, it is.
Especially if your professor doesn't use calculators.
Oh, there you go. And yes, especially if your professor doesn't let you use calculators on a test. This first test, I might have a part where you're not allowed to use calculators. So hopefully you're not too umbilically attached to them. Let me think. And then 5, you guys should know. Dear God, if you don't know 5, then I got to just leave. 5 goes in any number ending in 5 or 0. 6 we talked about. 7 is a poor dude. There's no rule for 7. There's no pattern to 7. Poor little 7. 8 is freaky. It's the last 3 have to be divisible by 8. That's a harder one. 9 is if they all add up to be multiple of 9. And 9 goes. Okay, that's enough of it. Sorry. You guys are starting to daze off. The last couple of things I want to talk about from chapter 1. Let's see, where'd you go? Oh, don't worry too much about that. Here. Now, hopefully you guys know this, but for example, we talked about this just a minute ago. What's x plus x plus x plus x? 4x. So somebody had to write a bunch of x's, and they're like, I'm tired of writing all these x's. I'm just going to let everybody know that the 4 in front means that many added. This is not far from the truth. This is basically how it happened. Every math symbol that we ever use, in fact, even the symbols for the numbers, had to be created at some point. Aliens didn't come and say, use this or we will blow you up. Okay. No, we had to make them up. So what is x times x times x times x? X to the 4th. That poor dude was like, oh shit, that guy put a 4 in front already. I got to put the 4 somewhere else. Let me just put it up there so it doesn't look like it's divided if it's on the bottom. I'm just going to put it up there. Do you guys understand what I'm saying? I mean, I think this is part of students' trouble with math is you don't stop to realize somebody had to make this shit up at some point. It's just an agreement about what it means. So you're really just agreeing with, okay, you guys chose that way. I understand what you mean. Fine. But then all the properties of powers come off of this definition. So for example, who remembers what x to the 4th times x cubed? X to the 7th. Because what would that? X to the 4th is 4 x's in a row. And then I have another 3 x's in a row. So of course total I got 7 freaking x's in a row. What definitely makes students wonder about if I took my meds this morning is when I say there is no 4 in this. There's no 4 anywhere up here. What does that mean? There are 4 x's. There's no 4's anywhere. There are 4 x's, 3 x's, so of course there's freaking 7 x's at the end. Alright, that's a little bit too early for properties of exponents, but I just wanted to throw that at you. What was the other thing? There's one last thing. Blah, 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 blah. Oh, here's the one last thing. Somebody was asking about this before. Absolute value. What are the absolute value symbols? What do they look like? I like it. So the straight lines. Where are they in order of operations? The same place as parentheses. They're just parentheses that kind of stood up straight. What is an absolute value symbol? What does it mean? Kick ass. All right, I love it. So if you didn't quite hear that, it's the distance between the number and 0. That's why the absolute value always comes out to be positive. Because even if I face this way, you are not negative 4 feet away from me. I mean, that would be like inside me.
Quay.
No? Total recall. So absolute value, so the absolute value of 4 is 4, because 4, of course, is 4 steps away from 0. What's the absolute value of negative 4? Still freaking 4, because negative 4 is 4 steps away from 0. I like it. So what is this? Oh, Jeff, why? What is negative absolute value of negative 8? Yeah, what's the absolute value of negative 8? 8, and then you put a negative on it. So the answer to an absolute value is always positive. So that absolute value is positive 8, but then somebody put a negative in front of it. Oh shit, so the answer is negative 8. I like it. I like how everybody's like, I sense it's getting close to the end, but I see a lot of people doing this. That's kind of related to this, evilness. The difference between these two things here. You guys remember this? One of these is positive, one of them is negative. The first one is good because it's negative 2 times negative 2. Why? And the reason that two negatives cancel is because negative means the opposite of. So if I said the opposite of, so what's the opposite of hot? So what's the opposite of hot? Hot. All right, the two opposites kill each other. That's why any pair of negatives will kill each other. So don't make too much out of that. Now, when I combine negatives, that's like combining debt. When I put debt with debt, do I suddenly get positive? No, it's still freaking negative, right? It's only when you multiply. So this one is going to be a single negative sign in front of two 2's, and that's why that one is still negative 4. People put this in the calculator, and then they say, it gave me the wrong answer. No, you put in the wrong problem. Poor little calculator. I like it. Okay, so that is basically chapter 1. You have desperately got to, if you've already met in the labs, you want to keep working on that chapter 1 homework, you can work on that at home. If you're about to meet with me, we'll get started with that right now. Exactly, because we haven't started. Now, hey guys, I did post chapter 2 homework in my math lab, so if you want it, if you finish chapter 1, start up on chapter 2. Oh, you need...
I was trying to show you
Oh, the 298.
298.
Yeah.
Well, it turns out I don't need it. It's too much math for me because I only need to get up to 110.
Oh, I got you.
So they didn't let me type it. So, which sucks because I spoke to the counselor and she totally like, yeah, go for it. And so now I